So hello, everybody, and welcome to AMS Weather Band's latest webinar. This is the 2022 Atlantic hurricane season, a highly abnormal average season, with Phil Klotzbach, Stephanie Zick, and moderated by Doug Hildebrand. Now, folks, before we begin, I would like to address some of the ground rules for our webinar today. If you have any questions during the webinar, please put them in the Q&A option at the bottom of your Zoom screen. If you look at the bottom of your Zoom screen, you'll see the chat option. It's to the left of that. It just says Q&A. Click that button, enter any of the questions that you may have in there, and make sure that it's not put in the chat, because this way we can concentrate all of the questions and address them all in one spot, and it's we don't have to wade through a lot of other things. So any questions submitted in the chat option might get ignored, so please make sure that that's where you put your questions. And we will also have some time for questions either during the presentation or at the very end, depending upon how things flow and the preferences of our guests. So fear not, we will get to those questions. But yes, first I would like to introduce today's guests and our moderator. So Phil, Stephanie, Doug, thank you for joining us today. Our moderator for today is Doug Hildebrand. Now, Doug currently serves as the National Weather Services Service Preparedness and Resilience Program Lead at NWS headquarters in Silver Spring, Maryland. In this role, he leads the Weather Ready Nations Ambassadors, Storm Ready, and Skywarn programs. Doug is currently the AMS chair of the Weather Band Committee, a member of the newly established Committee on Spirituality, Multi-Faith Outreach, and Science, or COSMOS, and recently transitioned from current to past commissioner of the Weather, Water, and Climate Enterprise Commission. Doug received his Bachelor's of Arts degree in Geology from Bucknell University, a master's degree in Geology from the University of South Florida, and a master's degree in Meteorology from North Carolina State University. So welcome, Doug. Today's presenter is Phil Klotzbach, and he is a research scientist in the Department of Atmospheric Science at Colorado State University. He received his PhD in atmospheric science from CSU in 2007. Phil has worked in the Department of Atmospheric Science for the past 22 years and was co-author on the Atlantic Basin hurricane forecasts with Dr. William Gray through 2005. Phil became the first author on the seasonal hurricane forecasts in 2006. Phil also developed the 2-week forecasts currently being used during the peak months of the hurricane season between August and October. He has authored over 100 articles in peer-reviewed journals such as Journal of Climate and Weather and Forecasting. Phil graduated from Bridgewater State College with a BS degree in geography in 1999, and after receiving his master's degree from CSU in 2002, Phil thru-hiked the Appalachian Trail from Georgia to Maine, 2,100 miles, and he has also climbed all 54 14,000-foot peaks in Colorado and has completed 9 marathons and 6 ultramarathons. And I'm exhausted just reading that. So credit to you, Phil. And today's co-chair is Stephanie Zick. She's an assistant professor of meteorology in the Department of Geography at Virginia Tech. She received her PhD in geography from the University of Florida in 2016. She also holds MS Meteorology and BS Meteorology degrees from Penn State University and Rutgers University. Her research uses spatial methods to better understand hurricane dynamics and structure, and she is the author and co-author of peer-reviewed journal publications in multiple geography, geoscience, and atmospheric science journals. She has served as PI and co-PI on 2 National Science Foundation grants and a collaborative National Weather Service research grant from the University Corporation for Atmospheric Research, or UCAR. At Virginia Tech, she teaches multiple courses for the BS Meteorology degree, including tropical meteorology, numerical weather prediction, physical meteorology, and undergraduate research. She is an incoming member of the American Meteorological Society's Committee on Weather and Forecasting, and she also serves on multiple diversity, equity, and inclusion committees at Virginia Tech. So, welcome to our esteemed guests. And I will now give the floor to Doug. Doug, the floor is yours.
Thank you, Gideon. And clearly, none of us were in a hurry to escape college days. I know, I think I counted 9.5 years for myself. I'm sure with the 2 PhDs, it was quite a few years as well. So thank you, Stephanie. Thank you, Phil, for joining us. And I love sort of, Phil, you sent in a suggested title for this talk. And I love a highly abnormal average season. So let's just get right into it and, kind of explain what you mean by all of that.
Yeah, thanks so much, Doug, and thanks so much, Stephanie, and thanks, Gideon, too. Thanks so much for having me. And I'm going to just start with a brief slideshow, just kind of laying out a few of the things kind of that we saw during the 2022 season. It'll probably take about 10 minutes, and then we obviously have a ton of time to kind of dive in to questions. And I certainly can say I don't have all the answers to exactly what happened in the 2022 hurricane season, but I would say it is certainly the most abnormal normal hurricane season on record, or at least in my memory. So just to kind of highlight the numbers that we saw in 2022, overall, the numbers did come out pretty close to average. An average season has about 14 named storms. So those are systems named by the National Hurricane Center, winds of 39 miles per hour or greater. So that's tropical storms and hurricanes. Of those 14, 8 of them became hurricanes. An average season has 7. And of those 8, 2 became major hurricanes. An average season has about 3. The 2 major hurricanes in 2022 were both very, very impactful. Hurricane Fiona obviously caused a tremendous amount of damage, flooding damage in Puerto Rico, as well as a lot of wind and storm surge damage up in the Atlantic provinces of Canada. And then certainly Hurricane Ian as well, causing a huge amount of damage in Southwest Florida, and unfortunately over 100 fatalities attributed to that storm as well. There are a variety of other metrics that we forecast as well, some day metrics, so how long these storms last. And then there's this geeky metric known as accumulated cyclone energy. That index takes into account storm frequency, intensity, and duration. And you can see that was a little bit lower than the 1991 to 2020 average. And again, we had the frequency, we had the intensity, but we didn't have as much duration in 2022. Overall, CSU, our group at CSU has been doing seasonal hurricane forecasts all the way back since 1984. As Gideon mentioned in the introduction, I had the great privilege to work with Dr. Bill Gray for about 15 years, and Dr. Gray pioneered these seasonal hurricane forecasts back in 1984. So this coming year will be the 40th year that our group has issued seasonal hurricane forecasts. But you can see that overall, our forecasts over-predicted the full hurricane season. We started with an above normal season. We actually increased the numbers in June and July, and then decreased them somewhat in August. And when we get into the questions and answers, I'm happy to explain kind of why the numbers went up and down with the various forecasts that we issued. But we have been doing this for quite a while. And so with these seasonal forecasts, again, we forecast that accumulated cyclone energy metric. And I think what I wanted to highlight here is just, we didn't see a lot of storm tracks in the Eastern Atlantic. So a lot of that was probably due to copious amounts of dry air, especially early in the season. But if we look at these tracks of storms, here, purples indicate major hurricanes. The red lines indicate category 1 and 2 hurricanes. The yellow lines indicate tropical storms, and the green lines tropical depressions. And the orange line is subtropical storm. That was from Nicole before it became a tropical storm, and then a hurricane right before it made landfall. But we don't see many tracks in the Eastern Atlantic. And accumulated cyclone energy, again, is frequency, intensity, and duration. And we didn't have as much duration this year because obviously if a storm forms off of Africa and intensifies fairly quickly into a hurricane, it can generate tremendous amounts of that accumulated cyclone energy because it's out there for quite a while. For example, Hurricane Irma in 2017, which I'm sure many of you are quite familiar with, generated a tremendous amount of accumulated cyclone energy because it tracked all the way across the Atlantic basin and for a long period was a category 4 and even a category 5 hurricane. Just to briefly highlight the landfalls, we had 3 storms make landfall in 2022. First, Colin as a tropical storm in early July. And then we had Ian made landfall as a category 4 hurricane near Fort Myers Beach, then made a second landfall in the northern part of the South Carolina coastline as a category 1 hurricane. And then late in the season, we had Hurricane Nicole make landfall near Vero Beach, Florida, I actually was going to visit family. And I was supposed to arrive the Wednesday that Nicole made landfall. And certainly when I planned that trip a few weeks out, I didn't expect the Orlando airport to be closed due to a hurricane. It was the latest hurricane to hit the east coast of Florida on record. And records go back well over 100 years. So that was an impressively late hurricane. And it did cause some damage, obviously not nearly as much damage as we saw from Hurricane Ian, which at current estimates from NOAA are at least $50 billion in damage. They'll probably be fine tuning that estimate as time moves along in the next couple of months. But to kind of get back and look at our forecast track record. So CSU, again, we've been doing this since 1984, and here we're just looking at correlations. And so these are real-time forecasts going back nearly 40 years. So here the reds indicate the last 9 years. So we did a big change in, we upgraded a bunch of our models. We started doing some new forecasting approaches after 2013, which was the biggest forecast bust that our group at CSU has ever had. For example, we forecast, depending on the outlook, we forecast 9 hurricanes, I think was the most common number we forecast, and we got 2 in 2013. So certainly not a good forecast. So we spent a lot of time trying to basically improve the seasonal forecasts after 2013. And I think you are seeing improved skill in recent years. Obviously, 9 years is not a very long time period for correlations, but we do see improvements in skill. And I think that's somewhat due to better statistical models. We have better historical data now to build our models off of. It's more reliable than the older data. And also we are starting to incorporate statistical dynamical models, which basically uses a climate model, such as the European Center for Medium Range Weather Forecasts, ECMWF model, to forecast the large scale environment, and then using that forecast of the large scale environment to then forecast overall levels of hurricane activity. So for example, if the model says shear is going to be low over the Atlantic, that the waters are going to be warm, you should generally have a busier hurricane season. So overall, we do see, in real time, the April forecast, which started in 95, hasn't shown skill, but it has shown skill in recent years, and improved skill in June and August, which makes sense because you're closer to the events that you're trying to predict. One thing I like to point out is that while the hurricane season officially starts on June the 1st, it doesn't really ramp up until we get into August. So August gives us kind of one last shot to kind of fine tune our numbers. It also gives us one last shot at a mulligan if you realize we really have blown it up to that point. So with the August forecast this year, we did lower the numbers, not as much as we actually in retrospect should have, but we did bring the numbers down because we saw some things that indicated that the season wasn't going to be as active as we had anticipated, especially with our June and July outlooks. Just another way to look at the track record of CSU's forecasts. Here we can see the forecast of the overall number of storms with our early August outlook. And you can see overall, the correlation is 0.79. So explaining about 60% of the variability going back 39 years. And that is one thing with these seasonal forecasts is you're never going to get correlations of 1, because the idea with a seasonal forecast is we're trying to predict overall what the large scale environment is going to look like. And so basically, if the environment has lower shear, if there's more moisture, if the waters are warm, you generally are going to get more storms. But exactly the exact number of storms and how those storms play out is governed by day-to-day weather patterns, which we can't predict on seasonal timescales. So kind of the large-scale environment loads the dice, but even perfect knowledge of the large-scale environment only gives us so much information about exactly how busy the hurricane season is going to be. But overall, the forecasts do show skill going back 39 years with real-time forecasts. So now to kind of dive in and talk about what we saw in 2022, one of the big players that we've seen in 2022 and even going back the past couple of years was this continued La Nina. And so here we're looking at sea surface temperature anomalies or differences from the long-term average. Reds indicate warmer than normal, blues indicate colder than normal. And we can see sea surface temperatures in the tropical Pacific Ocean, in the eastern and central tropical Pacific, much colder than normal. And in the Atlantic, they were warmer than normal. However, one thing I do want to point out is that we also have that cold blob, a highly scientific term, the cold water, anomalously cold water in the eastern and central subtropical Atlantic. I think that actually was one of the important things that really caused August to be very, very quiet. And we can go into a lot more discussion of that once I finish this presentation. But overall, we did have these La Nina conditions in the eastern and central tropical Pacific. And going back all the way to Bill Gray's pioneering work in the early 1980s, La Nina is typically associated with busier Atlantic hurricane seasons. And so the reason why that's the case is because when you have that colder than normal water, what that tends to do is basically in the tropical oceans, you have what's known as the Walker circulation. And so basically when you have La Nina event, you tend to have a stronger Walker circulation shifted farther westward, and out of that is upper level divergence. And so what that results in the tropical Atlantic is generally less vertical wind shear in La Nina events than in El Nino events. So here's a vertical cross section in the tropical Atlantic. So typically your low level winds are the trade winds, so blowing out of the east. Your upper level winds blow out of the west. And so when you have a La Nina, you get either reduced westerly winds, and a strong La Nina, you can even get upper level easterly winds. So you have much less vertical wind shear. Whereas in the tropical, in an El Nino event, you tend to get a little bit stronger low-level trades, but much stronger upper-level westerlies, more shear, and overall fewer hurricanes in the Atlantic, just given the overall environment is less conducive. Remember, hurricanes thrive in low shear environments. Basically, hurricanes like to be upright. If you get too much shear, it basically tilts the hurricane vortex. You're unable to get the pressure fall that you need. It also encourages entrainment of dry air that chokes off the thunderstorms that are the building blocks of the hurricane. So what do we see in August through October of 2022? Well, here's a 3-month average plot of vertical wind shear. So here blues are lower than normal shear, reds are higher than normal shear, and you can see, and this black rectangle highlights what's known as the main development region. And you can see in general, the shear was higher across a large part of the basin, much higher than what you would expect, given overall the La Nina conditions. And often we look at these 3-month averages because August through October are the peak 3 months of the Atlantic hurricane season. You get about a little over 90% of your hurricane activity on average during the month of August through October. However, I think using a 3-month average doesn't necessarily tell the whole story of 2022. So here we're looking at accumulated cyclone energy. So again, that integrated metric. And so reds are average and blues are 2022. And so obviously a big thing that stands out is there's no column in August of 2022. We had no accumulated cyclone energy, no named storm activity from July 3rd through August 31st. The next storm formed, Danielle, on September 1st. That was the first time that July 3rd to August 31st it had no named storms since 1941. If you're a baseball fan, that's the year Ted Williams hit 406. So it's been a long time since we had an August with July 3rd to August 31st with no named storm activity. The last August to have no named storm activity was 1997, which was a strong El Nino year. This is the first year on record to have a La Nina and no storms during the month of August. But that was followed up with quite a busy September. 6 named storms, 4 hurricanes, and then the 2 significant major hurricanes, Fiona and Ian. And that was then followed up by a very quiet October with just 2 storms and 1 hurricane. Let's see, it was Julia was the hurricane, and then Carl was a weak storm in the Bay of Campeche. And then lastly, we ended up with a busy end of the season. We had a flurry of storms. We had Lisa, which was a hurricane in the Caribbean, Martin, which was out in the open Atlantic as a hurricane, and then Nicole late in the season making landfall as a hurricane in Florida. So a busy end of the season. So quite an erotic season. Often, either if September is busy, August or October will also be busy. So to have a busy September and quiet on both shoulder months was quite surprising. And there's a lot of reasons why, but just looking simply at vertical shear to start, if we look at August, we can see kind of a dipole pattern where you have high shear in the Western Atlantic, lower shear in the Eastern Atlantic. And so, this kind of would indicate to me, you're not going to see much in the Western Atlantic because you have high shear. What was more surprising was that we didn't have any storms in the Eastern Atlantic, but there was a lot of dry air that was present. And so the question is, why was this shear pattern there? And this shear pattern of like high shear, basically in a southwest to northeast oriented axis from the Western Caribbean extending northeast, is a classic signal of a robust tropical upper tropospheric trough or strong upper level low. And so what happens when you have this strong upper level low is that tends to increase westerly wind anomalies into the deep tropics. And why was this a strong upper level low there? Why did we have more of these mid-latitude incursions into the tropics? I think some of that was due to that sea surface temperature anomaly pattern that I showed earlier, where the tropical Atlantic was warm, the subtropical Atlantic was cold, and so you have a stronger temperature gradient between the tropics and the subtropics. That increases frontal activity, increases effectively baroclinicity, and you're able to get more basically upper level lows, more cold lows coming into the tropics. And when that occurs, you have more shear, but also more dry air because the mid-latitudes tend to be drier than the tropics. And so August overall had higher shear, a lot of dry air, and was a very, very quiet month. And I should mention, with our August forecast, we did lower the numbers somewhat because of that stronger sea surface temperature gradient between the tropical and subtropical Atlantic, because that does sometimes lead to a more vigorous upper level trough. However, we have seen other years with a very similar sea surface temperature pattern, such as August of 2011, where we had a very, very busy month. We had 7 storms and 1 major hurricane in August of 2011, that major hurricane being Irene. So it's one of those things where if you put all your eggs in that basket, you're going to get burned sometimes. So, but this is certainly something we're going to be looking at in more detail as we move ahead and start looking towards 2023, and as we continue to always be working on our seasonal forecast models. Then if we flip gears to September, the shear pattern basically went from high shear in the west, low shear in the east, to low shear everywhere in the deep tropics. And we had a very busy month for storms, 6 named storms, 4 hurricanes, and again, Fiona and Ian being the biggest stories of the year. And obviously both those storms were quite impactful, and we had a very, very busy month. Then in October, the shear pattern almost was a complete opposite of September. We had higher than normal shear. If you were to show me this shear pattern, given the large scale environment, I would say this is a strong El Nino. But it was during a La Nina. I think there was some tropical circulation changes. In addition to La Nina, we have what's known as the Matt and Julian oscillation, which is variability on shorter timescales on about 30 to 70 day timescales. And as that propagates around the globe, it can basically alter lower and upper level wind patterns to either kind of reinforce La Nina conditions or to basically counteract them. And it was quite robust. And basically what happened was it forced a lot of subsidence over Africa, and emanating out of that subsidence over Africa, you had upper level convergence. And if you have subsidence over Africa, those winds lagging that upper level convergence are going to be blowing out of the west. And I think that's one of the reasons why we saw really those high shear anomalies persisting across the Atlantic for most of October. One last thing before we start looking and diving into some questions is we do have a website that our group at CSU has put together with the Barcelona Supercomputing Center, who really spearheaded the effort. It's called seasonalhurricanepredictions.org. We have 28 different groups submitting seasonal hurricane forecasts to this website. They include private sector weather companies, government agencies such as NOAA, and then universities such as ourselves at CSU, Coastal Carolina, University of Arizona. One interesting point to note is we actually have more contributions from universities in landlocked states like ourselves in Colorado than from states that actually border the Atlantic Ocean. They used to ask Dr. Gray, why do you issue seasonal forecasts from Colorado? And he used to say it's because the storm surge can't get you at 5,000 feet. And so when you look at the seasonal forecast from 2022, if you look at the overall number of hurricanes, the average of all the different forecasts verified quite well. We did end up with 8 hurricanes, which is what the average of all these different forecasts were. So if you want to go to the website, all the forecasts are currently color coded based on the type of agency. So here, purples are private sector weather companies, reds are government agencies, and blues are universities. We actually will be redesigning the website for the 2023 season with a fresher look and some new programming as well to kind of help improve things. But on the website are the forecasts themselves, details on what each of the different groups uses. So to give you an idea of just kind of, CSU, we've been doing this the longest, but there's a ton of other groups doing these seasonal forecasts as well. And if you're interested to kind of see what other groups are saying, this is a useful resource for you. So with that, I will stop sharing my screen and we can dive into questions and discussion.
Wow, Phil, thank you so much. I mean, just so many slides that I'd love to further dissect. And we have one question, and then as others are formulating their questions, I do want to pass it off to Stephanie and get her first thoughts as some of the information that you presented, and maybe even her just experience over the last 4 or 5 months on her observations. Stephanie.
Okay, yeah, sure. So, Phil, thank you for that. What was remarkable to me through the beginning of the season, especially, was the lack of activity. And you talked about that a little bit, especially like no activity in August. Can you speak a little bit more to that? I know that the African easterly waves activity was very robust, and the shear wasn't that negative of an impact in the East Atlantic. So can you speak a little bit more about that?
Yeah, so I think a lot of that actually came from dry air that was present more in the Eastern Atlantic. So yeah, if you look at the shear, I tend to focus a lot on shear. And so if you look at the shear, you would say, okay, I wouldn't expect long track storms because they basically would hit that tropical upper tropospheric trough and get sheared to death at about 50, 60 west. But why stuff didn't form right off of Africa was likely due to lots of dry air. And so typically, why August isn't as busy as September, shear overall in August is actually even a little lower than the shear in September. But it's that typically the thermodynamics aren't as conducive early in the season. Some of that is due to the waters are just cooler. The waters continue to warm up from August to September. And then also you still tend to be getting a lot of dust outbreaks from the Sahara. And so those were present in August, but they weren't massively robust. They actually were, the dust was actually a little lower than normal. And it seemed like a lot of the dry air was actually emanating out of the mid latitudes, both from that kind of upper tropospheric trough in the Western Atlantic, bringing in mid latitude air. But I think there was also a considerable amount of northerly flow in the Eastern Atlantic too, bringing drier air down from Europe. So I don't think it was all necessarily to blame, because typically you see dry air, it's like, oh, it's dry air coming from Africa, but I don't think it was all from African origin. I think there was a lot of mid-latitude origin to it, and we're currently working with some colleagues to kind of try to unpack that and quantify that using some tracers to better be able to understand exactly what percentage came from what. And then we can revisit that in a couple of months and realize, is what I'm saying true, or is this completely wrong? So we should have a better idea of that, hopefully in a couple of months once we quantify that in more detail.
Can you sort of speak to how anomalous that was, the dry air this year?
Yeah, it was pretty dry. Let me, I do have a more in-depth presentation. So what I will do is I will pull up that slide deck. And then I will share my screen. Here we go. And so if we look at this slide, here is mid-level moisture. So this is at 600 millibars. And you can see that in general, across most of the tropics, it was pretty dry. So you're talking 4 to 8, maybe as much as 10% drier, or the relative humidity was 4 to 8% lower than what you would expect. So there seemed to be some stability issues as well. It was just more stable. And you could see that the waves as they came off Africa, they just didn't really, they just kind of came off the coast and died. But yeah, if you look, all you look at is, the strength of the waves themselves, that they weren't, particularly weak during the month of August. The circulation over Africa was relatively favorable. And to me, one of the things I think that was most interesting was when we put out our early August forecast, we even said in there, we don't expect much the next couple of weeks, but then late August, the tropical circulation should become a lot more conducive. So I would have expected, had we talked August 5th or whatever, that yeah, through August 15th or so, the season would be fairly quiet. And then around August 20th, which is the time historically, Bill Gray would ring a bell signaling the busy part of the season. The bell would ring and the storms would come. And it was about 12 days where nothing happened. And then the storms finally came. And I think there was definitely some stability issues that really kind of hindered stuff that last, say, week or two in August, that I think was something we really weren't expecting. And even the climate models forecasting 1, 2, 3 weeks out, the ensembles were generally fairly robust for storms, and we just didn't see anything. So I think that to me is, even in August, the first half of August, I think we were kind of expecting would be quiet from, say, August 1st, that we wouldn't expect much the next 2 weeks, but as those last 2 weeks in August, that still being quiet, I think was really surprising. I think had you asked me, August 15th, what was going to happen, I would have certainly expected at least one hurricane, if not two, by the end of the month. And that kind of highlights, when it comes to seasonal forecasts, our skill largely derives from the tropics. The tropics have a lot of persistence. They're a lot more predictable. Whereas the mid-latitudes, as we know, living in the mid-latitudes, the weather in the mid-latitudes just tends to have a lot lower predictability to it. And so when the mid-latitudes are kind of driving things, that can really kind of lower your predictability, I think, on a seasonal time scale, but also even on shorter time scales. And again, we saw that with a lot of the climate models in the ensembles tending to be a lot more bullish, because I think they were also looking at the tropical environment saying that should be conducive, and the mid-latitude environment just not really playing ball to get stuff going until we got to early September.
Yeah, thank you for that. There are a lot of questions coming in. I'll just say one more thing, because I know this is what I told my tropical meteorology students, but like early season, yeah, it tends to be not too favorable. It tends to be dry in the Eastern Atlantic, and there tends to be a lot more stability. But then usually by mid to late August, some maybe development or just rising motion, right? There's a lot of potential instability or conditional instability in the tropical atmosphere. So you just have a little bit of rising motion will destabilize the atmosphere. And we just weren't getting that until basically early September, and sort of paving the way for more activity. Do you agree?
Yeah, and sometimes you really kind of need that quote unquote sacrificial lamb wave, easterly wave that won't necessarily develop, but it'll kind of moisten things up. And it just took a long time to get stuff firing. And even throughout the season, it seemed like convection was always a bit of a challenge to get stuff to actually convect and fire. And we, especially with Ian, digressing and looking at Ian, if we looked at Ian, I went out hiking all day on Sunday and came back and was out of cell service, came back, and it looked like nothing. Like it was just a big sprawly mess. And then finally, the low level and mid level centers aligned, convection fired, the pressure dropped 11 millibars in 2 hours, and it was off to the races. But convection seemed to be challenging this year. It seemed to be hard to get convection to really fire. And so it definitely seemed like dry air was one of the big challenges this year. We don't use dry air on in a seasonal forecast. We don't use what is the average 600 millibar relative humidity or something like that, because first of all, historically, I don't think we've done a great job measuring it. It's harder to measure mid-level moisture going back, say, 40-50 years. But also, I don't think necessarily a linear relationship as well, because the atmosphere needs to be moist enough, but it doesn't necessarily want it to be too moist, because if it's too moist, you need to kind of concentrate convection. And if basically it's really moist, you get all this pop-up convection, but you don't want that. If you're looking for a hurricane, you don't want too dry, because then you just get too much entrainment and that kills stuff. But if it's too moist, that's not necessarily a good thing for hurricanes either. So moisture is kind of one of those tricky things where you want enough, but maybe not necessarily too much.
Yeah, it is. All right, let's do some of the questions. I'm gonna mostly go in order, but I'm gonna take the third question first, because I think it really relates to your talk. Is there any methodology to forecast the TUT?
Yeah, and so there's actually been papers. So both Jordan Jones, who got a PhD in our group, has looked at this, as well as Ro Wong and her students at the University of Illinois. And if you look, we had a predictor that was very closely tied to the TUT with our early April forecast, looking at upper level winds and kind of basically in those persistence. And it was about half a standard deviation high. So basically saying the TUT looked like potentially it was going to be a little bit more vigorous. And so that kind of lowered the forecast in April from what it would have been otherwise, but still wasn't as gangbusters as obviously it was. And if you look at Ro Wong's published work that she and her students have done, it generally ties to what's going on in the tropics. And I believe I don't have the model itself, but if you look at the predictors, it would have forecast generally a fairly low TUT in 2022 because the TUT tends to be closely related to ENSO. So you tend to have a more vigorous TUT in an El Nino, and obviously we did not have El Nino. So it's tricky to forecast because there's the tropical forcing of the TUT, which that's fairly straightforward. Usually August 1st, you know what El Nino is going to be for that month. But when it's more being mid-latitude forced, that's tricky. And so I kind of hand waved and said, oh, you know, the stronger subtropical, tropical temperature gradient likely force a stronger TUT, but it doesn't always work. And so the correlation is not particularly high. So there's definitely, I think, a fair amount of unpredictability to that TUT, again, because I think it has both tropical origins, but also it has mid-latitude forcings as well. And I think it's the mid-latitude forcings that are what really causes the challenges with us on month-to-month and seasonal timescales.
Okay. So there are a couple questions about potential changes to your methodology in future seasons. So I can maybe group them together. Will you change any of your methodologies based on this year's pattern and especially the relative humidity contribution? That's the first one. And then the second one is, do you think your predictions would improve if you included buoy observations that had subsurface temperatures and salinity profiles?
Sure. So with regards to the moisture, I kind of already briefly talked about that. It doesn't work great on seasonal prediction timescales. And I think, again, usually when we do these things, you are using like area averages. So, you know, look at the, you know, area average moisture in a certain region. And part of it is that, so when you look at seasonal forecasts, or we look at this hurricane season, we talk about the waters, we talk about the shear, we talk about pressures, instability, but they all correlate really, really highly together. So generally, if you have warm waters, you generally have weaker trade winds because that helps to keep the waters warm because you have less evaporation and mixing. When you have weaker trades, that tends to be coupled with weaker upper level easterly or upper level westerlies, which means lower shear. It tends to be associated with lower pressures, which means a more unstable atmosphere. And so if you take one of those things and that's your predictor, everything else kind of correlates really strongly with it. So if you're trying to improve the variance that you can explain, you don't get a lot of additional variance if, say, you look at shear and then you say, let's add the sea surface temperatures. Doesn't really give you any really new explained variance. And so moisture is kind of that same way. Once you include, say, shear, and you look at the variability that could be explained by moisture, it's very, very low. And I think some of that may be, again, due to the fact that historically it's in reanalysis products, but they're not always, it's one of the wonkier fields. I don't think we measure it super well. And it also depends exactly which layer you look at. And so there's certainly stuff we are going to be doing for 2023. I mean, one thing that is important to realize is if a forecast, you know, I wouldn't say necessarily this is a bust, given I've had some royal busts. Like this is a over forecast, but certainly not as much of a bust as I thought at the end of August. Is you want to be careful not to like overreact and completely throw everything out. But it's certainly also important to realize, hey, we didn't get this season as well as we could have. And so I think one thing we will be doing is we will be weighing the wave breaking predictors, the top predictors that we have, a little bit stronger, because it does seem to be, it's definitely played a role. So giving them additional weight in 2023 and beyond. It is tricky because our statistical dynamical models, which have helped us a lot in recent years, most of the climate models were also very, very robust for the season, forecasting low shear, warm waters, and it didn't pan out as a forecast, and that's a little tricky. And so one of the things I like about those statistical dynamical models is a dynamical model is looking forward, where our statistical model is looking backward. And so, you know, one of the things I was hoping is that when you have those, it can give you kind of a sanity check. Whereas if you're all your historical data saying a busy season, but the climate models are all saying the shear is going to be super high, hey, we need to take a look and see what the heck's going on. Whereas this year, everything was pretty much on board for a busy season, especially in June, which is why our forecast went up in June. Everything kind of started to back stuff down by the time we got to August, but not to the level that we got. Now, with that being said, our early August statistical model actually came out more near average, but that was based on just the July large scale conditions, which generally were quite unfavorable. But if you look at, say, a longer period average of the last 50 days, it was more favorable. And it's also, I want to try to avoid the windshield wiper where you go high and then suddenly stuff changes and you don't want to go way, way low. So you kind of want to build in a little bit of inertia in the forecast. Obviously, in retrospect, I wish I had just gone with the last 30 days, but obviously you could also get burned doing that. So I think we will be looking more at wave breaking. We'll definitely be looking at if there's tweaks we can do to our statistical dynamical models. I think also too, looking especially at forecasting the TUT, because the TUT tends to be most robust early in the season. So trying to see, not necessarily predicting it seasonally, but really just trying to focus on August itself and seeing if we can get some sort of ideas to maybe some other things we can do to look at forecasting it in August, both from a statistical perspective, but also looking at dynamical models. But I don't think that dynamical models, I haven't rigorously looked at all of them, but given their sheer forecast, I don't think they did a particularly good job of forecasting how robust that TUT was going to be in August, even with initialization on the 1st of August.
When you say models, can you just be a little bit more specific? There was a question about the data that you use. So what model data are you using?
Yeah, so when it comes to historical data, we use the primarily use the ERA5, which is the latest reanalysis from the ECMWF. And so the ERA5, so basically reanalysis data is effectively historical, basically the best estimate of what weather and climate patterns look like in the past. And so basically prior to the mid 1990s, we really didn't have reanalysis. So basically like Dr. Gray would like call up people and get him to send him like station data from specific weather stations in the Caribbean, get balloon data. Whereas now we have these nice globally gridded reanalysis data sets. Some go back as far as the 1800s. Obviously, the farther back you go, the more uncertainty you have, both in the observations, but also in hurricane data. But since 1979, the data is pretty good. We had enough satellites to get a reasonably good idea of what things were doing. So from our historical data is primarily based on that ERA5, this reanalysis. And then when it comes to these statistical dynamical models, currently we use 3. So I use climate model forecast from the European Center, so the ECMWF, the UK Met Office model, which is Glossy 6 now, and then the Japan Meteorological Agency, their forecast as well, to kind of get ideas, not just from one model, but from 3 models, kind of what the large scale environment is looking like for the peak months of the hurricane season.
And is there a reason you don't use the GFS? Sorry.
Oh, the CFS? Yeah,
the GFS.
It was the worst performing of all the models I looked at. So the Copernicus website, which is a great archive of everything, had like 12 different climate models, and CFS performed the worst. So no.
Okay. So no, the person was wondering about the GFS, but you're not using like the GFS, just to be clear, you're not talking about like the GFS forecast model as one of your models.
Correct. So what I'm talking about is on the seasonal forecast, we're looking at climate models. So not day-to-day weather prediction, but more what's the forecast for the next like 2 to 3 months, not what's the forecast for like tomorrow going to be. Now, when it comes to our subseasonal forecasts, I do look at weather models. So then you're looking at the ECMWF weather model. I look at the GFS, and honestly, we're looking a lot for Genesis. And Genesis, you definitely want to look at the ensembles. Each of the ensembles has biases, which is kind of nice to know too, especially over the course of a year, you kind of learn which each model's biases are. And they can change year to year because they're always upgrading these systems. And so one model may have a bias this year, and then that bias may go away next year, or you get they overcorrect the bias. So, but certainly when it comes to the subseasonal forecast, we do use, I look at everything I can get my hands on, because I want to look both at what the models are doing with tropical cyclones, but also what the models are doing for the large scale environment. Because especially once you get to like week 2, the sheer forecast from say the GFS ensemble versus the EC ensemble versus the Canadian ensemble may be somewhat different. And it's good to kind of see what the spread is there as well.
Okay, great. Okay, this one's related to this past season. So the estimated impact of the Hungatonga, I cannot pronounce, but the volcanic eruption was recently upgraded to be larger than Pinatubo and assessed to have blasted a record amount of water vapor into the upper atmosphere. Do you think this had any effect on the Atlantic hurricane season?
I don't think so. And the reason why is because all that should have gone into the dynamical models, because the dynamical models should have known the water vapor that increased injection of water vapor was there, and they all forecast a really busy season. So I mean, I haven't done like a thorough diagnostic to look and see, but from a physical perspective, the model should know pretty much once it erupted, hey, there's this extra water vapor, and then adjusted the circulation accordingly. So I don't think necessarily that played too much of a role, but it's hard to say without kind of doing an experiment where you basically, you know, include the water vapor, exclude the water vapor, and see what plays out from that.
Yeah, in my experience looking with like reanalysis data, the upper atmospheric water vapor isn't very good.
Yeah.
So, I mean, I wonder if the models might not have forecasted that and the impacts very well, though, too.
Yeah, I mean, I honestly think one of the things that was really wonky this year was the fact we've had El Nino for 3 years, basically. And once you start getting to a third year La Nina, like the circulation over the tropical Pacific looked very much La Nina. It was extremely robust, but it wasn't. Normally in a La Nina, you kind of get this what's called like a wave number 1 pattern, where you broadly get rising motion over Africa and the Indian Ocean, sinking motion over most of the Pacific Ocean. And this year, that was there in September, but especially in October, that broke down. And so we ended up with basically rising motion over the Western Pacific, sinking motion over most of the Eastern Pacific, and then you had basically sinking motion over Africa. And that, I think, is really what torpedoed October. Because obviously had October just been average, given the busy November, it actually would have come out to a pretty, the forecast would look pretty good. We had to end up with an ACE of like 130. So it would have been, you know, basically, I always figure if I can get ACE within 20 points, I'm happy. That's about as good as we're going to get. But yeah, honestly, going back to the volcano thing, I really don't know for sure. I basically, the dynamical models, I maybe should have had it better, but I don't. It's one of those things where I don't know exactly how that would have specifically changed the Atlantic, but not other basins. I don't really have a great feel for how that would have been like basin region specific. I would assume like that would be kind of equally distributed, especially once you get, you know, a few weeks away from the eruption.
So there is a question about the MJO, and I had a question just sort of generally about the MJO too. So you spoke a little bit about sort of intraseasonally, how the MJO modulated the activity. So this person also wanted to know like how, so specifically they say, oh, it propagates west to east and it can change the upper level wind patterns. Can you just speak a little bit to this season, how that played out?
Sure, yeah. And so the MJO often is measured by what's known as the Wheeler and Hendon index, which was created by Wheeler and Hendon, so well named. And so basically the MJO is equatorially propagating convection. It propagates around the globe about every 30 to 70 days. So I am actually going to pop up a schematic I have of the MJO because it's a lot easier than just hand waving. Let me see.
It was really prominent this year, like, you know, September, I remember it was going to be favorable. MJO was going to make the atmosphere favorable in September and then not favorable in October was what I remembered. And it really affected the activity this year.
Yeah, and so if we look at, here's a schematic of the MJO from NOAA, which is really nice. And so this is basically showing, so this would be basically the optimal MJO for the Atlantic. So this is basically showing when it's enhancing convection over the Indian Ocean. And so the MJO impacts tropical cyclone activity globally. And in other basins, a lot of the modulation is, I think, more due to basically more favorable thermodynamics in addition to better or more favorable shear. But in the Atlantic, because basically once the MJO propagates across the tropical Pacific, once it gets into the eastern tropical Pacific, the waters are cooler. So it kind of loses a lot of the kind of the deep convection, but you still get the the wind anomalies, which I think is one of the big drivers in the Atlantic. So basically, when the MJO is enhancing convection over the Indian Ocean, you have low level convergence into those thunderstorms, upper level divergence. So if you think about this in a vertical cross section, you basically get low level westerlies, upper level easterlies, which counteracts your prevailing vertical wind shear. And so that tends to reduce shear and make for a busier period for Atlantic hurricanes. Alternatively, when it's maximizing convection over the Pacific Ocean, basically has the opposite effect. you basically have increased upper level westerlies, increased low level easterlies, which increases your vertical shear. And so if we look at this index in 2022, we basically had during late August, it was actually basically you had a La Nina and you had this over Africa. You had enhanced thunderstorm activity over Africa, Indian Ocean. So you would have expected a really busy second half of August, which is again, one of the big surprises to me was not the first half of August, but the second half of August, given tropical forcing was about as optimal as you're ever going to get. And we still had nothing. Whereas October, you had basically the MJO was trying to effectively enhance convection over the tropical Pacific Ocean. So basically trying to counteract the La Nina. And because the La Nina was so strong, it basically kind of broke down into a wave number 2 pattern. So we had, again, sinking motion over Africa. And that really, I think, is why we saw such high shear during October. But yeah, it's messy. And unfortunately, the MJO is weakest in the Western, it's weaker in the Western Hemisphere than in the Eastern Hemisphere. And it's also weaker in the Northern Hemisphere summer than in the Southern Hemisphere summer because of the Indian monsoon. So it's not, there's some years where it's strong and there's some years where it's weak. And so if you look at the MJO in September, it was extremely weak, but then in October, it was trying to really ramp stuff up over the Pacific, but because the La Nina was so strong, it kind of just stagnated over the tropical Pacific. And you ended up with kind of this weird pattern. So this is a phase space diagram that we use a lot to monitor the Madden-Julian oscillation. And so basically the distance away from the center of the circle is the amplitude of the MJO. So if it's near the center, it's weak. If it's away from the center, it's stronger. And normally it propagates from west to east. And so as it does so, basically it propagates counterclockwise around this circle. And so if we look at it, the red line is the late September, and you can see in October, the MJO basically amplifying in phase 6 over the Western Pacific, which is unfavorable. But then you see, it almost looks like a plotting error, right? It basically kind of goes up and down on that phase 6-7 line for about 10 days before it finally starts to propagate out of the Western Pacific over towards the Western Hemisphere. And so I think some of that was basically just because we had, some of it I think was due to the fact we had La Nina that was trying to counteract it. We also tend to have basically, I think, some equatorial Rossby wave activity, which basically when the MJO index kind of flatlines or even moves backwards or clockwise is when you have equatorial Rossby waves that propagate from east to west, basically counteracting the MJO. So there's a lot of, I think the MJO definitely played a role, but exactly how much was pure MJO versus other waves is a bit tricky, and I think needs probably some more work to try to quantify that. But overall, certainly when you have the MJO in those phases 6 and 7, regardless if it's pure MJO or if it's just that index is reflecting it, that indicates generally less conducive conditions for the Atlantic. And then once we kind of snapped out and moved more towards the Western Hemisphere, we had that last flurry of activity that we saw in 2022.
So there is a comment that I definitely want to get to because we're running out of time. So it's about how this season was abnormal, but it was very impactful, especially with Ian, and sort of that fine line there, and thinking about how do we communicate our forecasts. I lost the question. Let me see if I can find it again. Okay, yeah. So it was an abnormal season. It only takes one storm to ruin your life and damage and destruction to infrastructure. And yeah, do you have any thoughts about public outreach and how to communicate with the media better about the messaging that's going out?
Yeah, I mean, obviously, whenever we do seasonal forecasts, we always say one, I mean, obviously we forecast a busy season, and obviously it was extremely impactful. Obviously, Ian by far being the most damaging storm. One thing that we have shown is that historically in La Nina events, your odds of getting a $10 billion hurricane for Florida and the East Coast, so $10 billion normalized, so basically storms that when they made landfall, if they were to make landfall today, would cause at least $10 billion in damage. So taking the damage that occurred at the time and adjusting for population and inflation and wealth. The odds in a La Nina year for Florida and the East Coast is about 40%, and El Nino is 3%. So even though the season ended up, normal, we got that major impactful hurricane for Florida and the East Coast. When it comes to seasonal forecasts, we always say, it only takes one. In general, busier seasons have more landfalls just because you're effectively throwing more darts at a board. You can get lucky and have a year like 2010 with 12 hurricanes and no landfalls. You can get really unlucky like 1992, where Bill Gray had a great forecast of only one major hurricane, and there was only one. It just happened to be Andrew. And so in general, though, we do say, if you look historically at seasonal forecasts from CSU and then look at how many storms made landfall, take our 10 busiest years that we forecast versus the 10 quietest, you do see more landfalls and more impactful storms. But we always emphasize the seasonal forecasts are more for scientific purposes. It's a good exercise to do because we learn a ton. I think we've learned a lot more than if we didn't do seasonal forecasts. And it's a good kind of hook. I think the emergency managers often will use them. Obviously, if the forecasts are for a busy season, there's your hook. It's a forecast for a busy season, you got to get ready. If it's forecast to be a below normal season, they say, yeah, but in this below normal season, we had, XYZ storm that came in and caused all sorts of damage. So with the seasonal forecast, we always emphasize, though, like you mentioned, it only takes that one storm near you to make it a busy season. So I try to always say, busier seasons in general have more landfalls, because I don't like to give the message that it's a complete crapshoot, whether you get 2 hurricanes or 12 hurricanes, the odds of a landfall are the same, because they're not. But to the general public, you need to be prepared the same for every season. And if you look at preparation in general, in 2016, we were all talking about hurricane amnesia because we had this great streak of luck with very few hurricane impacts, followed by 2017, and obviously how busy we have been the last few years. So certainly, people in Southwest Florida next year are likely to be really ready to go for hurricane season, whereas obviously before they had a couple of impacts and had some brushes, and obviously, but in the case of Irma, going a little bit farther south, all the storm surge pretty much went into where not many people live. Obviously, had Irma gone 50, 100 miles farther north, we would have already seen what happened with Ian a few years earlier. And so the couple of near misses for the Fort Myers area, I think, are one of the reasons why we saw fewer people evacuate, because they just thought, oh, it can't happen here because these other storms have missed. Or we're like a Charlie, where it's a much smaller storm. It doesn't have the storm surge impacts that we obviously saw with a much larger storm like Ian.
So this is.
I tell my students that, the science is getting so good, I think. I focus a little bit more on, less on seasonal forecasting and more on things that are more relevant, like short-term forecasts. But I feel like our models are getting really, really good. But our challenge now is even if we have a perfect forecast, we need to be better at communicating it and managing the message better, getting it out to people who need it. So I think that's sort of what some of the comments are about too. What did you want to say, Doug?
I was just going to jump in. Awesome conversation from both of you, and great perspectives. And with the 2 minutes we have left, just a real quick lightning round, because Phil, I know you're on international travel pretty much in the next few hours to days here. One, do you take into consideration the multi-decadal oscillation? That's a very good question. So lightning round, yes or no type of
Yeah. So that you could have asked that question at 1 o'clock, and we could have discussed that till 2. Exactly. What is it? But long answer or very short answer, yes, we do. But mostly what we look at is, more what's going on a year-to-year basis. What do the water temperatures look like now? I think another thing that we have observed in recent years is a long-term trend towards La Nina, which is why in general the Atlantic has been more robust since the mid-90s. In addition to the Atlantic being warmer, this La Nina-like trend, in general, La Ninas do create busier hurricane seasons. Whether we're going to be moving away from La Nina for next year does look likely, but where we end up is remains to be seen.
Right. And then 2, is there is there any headline from outside of the Atlantic Basin that comes to mind globally for this?
Yeah,
last
yeah. I mean, it was an extremely, so not to say there were no impactful storms, but right now we're going to be pushing potentially the lowest global accumulated cyclone energy for a calendar year on record. It's going to be close. Obviously, it depends what happens in December, but it's been overall a quiet season globally, and that is typical of what you see during La Nina years. La Nina normally it increases your Atlantic activity and decreases your Pacific activity.
And I know we've come to the top of the hour, but real quick, say let's look into the future 10 years. What do you see being different from a seasonal outlook perspective? Do you think we'll get to, sub-basin scale, like, a Gulf of Mexico prediction, that type of thing, or other parameters that you're looking at?
Yeah, and so I think a lot of it is going to be more regionally based. So I mean, obviously, a lot of people are like, "Oh, it's a hurricane going to hit me in Houston," and we're never going to be able to say that in a seasonal time scale. Maybe a couple days in advance is about as good as we're going to get. I think as you move shorter time scales, so like sub-seasonal 2-week forecast, you can kind of highlight regions better. On a seasonal time scale, there are regions that tend to have more predictability. The Caribbean is one. That tends to have a lot of predictability. So I think we can do some stuff maybe for that region. And I think really more what we can do than necessarily saying where storms are going to track is highlight more where storms are likely to form. Because if storms form right off of Africa, those storms, you have Irmas, but in general, those storms are more and more likely to recurve than storms that form a little farther to the west. Those storms that say form 50, 60 west are very likely to impact somebody, whether it's Caribbean, Central America, the United States, Bermuda, Canada.
Great. Well, thank you both so very much, Stephanie and Phil. And if we didn't get to your question, we're going to do our best to try to get you an answer, whether it comes from Stephanie or from Phil. I know, Phil, you're going to have some commitments here, but Gideon, here you go. Thank you so much, everybody. What a great conversation.
Thanks.
Well, thank you very much, Doug. Yeah, thank you, Phil, and thank you, Stephanie. Doug, that was a great 2-minute drill. Very, very detailed. Appreciated that. But yes, Phil, Stephanie, Doug, audience, thank you so much for joining us today. That's pretty much all the time that we have. We will make this video available to Weatherband members at amsweatherband.org and at ametsoc.org. Audience, if you have further questions or you want to talk about the webinar, members are welcome to discuss on the Weatherband Community Forum. So please feel free to do that, and we'll keep an eye on that. And yes, thank you all for joining us today. That's all the time we have. Again, Phil, Stephanie, Doug, thank you so much, folks. Have a great remainder of your day.